Just like whenever we are observing them, we want to understand the limit. Okay. If I want to understand the limit, what to do? Just first of all, let us think that limit means just from the term limit, we want to just fix up limit of a number. Suppose x, yeah, x, algebraical term, x, y, z, whatever with the x. So now x is a variable. Variable means which is changing. It is taking the different values. That's why I'm just going to tell that it's a variable. Okay. If that variable is going to take a lot of values, variable values, but if I'm going to give this symbol x, limit, it is a symbol of a limit, x tending to 1, the value of the x, which is what are the values of the x, when x is taking the values, that is extremely nearer to 1. Limit x tending to 1 means LT, this is a limit, this means x tending to 1, মানে value of the x is extremely nearer to 1, মানে extremely near to 1 মানে কি বলবো, যেমন ধরো just like I can tell that x has a value 1.00000000001. X has a value dot, this decimal point is there, you have to think, so that one, but x has a value little bit more than 1, but it is extremely nearer to 1. Just if I'm just going to have a plot, so 1 2 3, in this way the x is having a extremely nearer value which is nearer to 1, because what is the amount, it is more than 1, 0.0000000, that much of extra value, more than 1 x, the x is possessing. Okay, but still whatever, that value is extremely nearer to 1, but still I just can think that a value x can take which is less than 1, but it is still extremely very near to 1, 0.99999. You can see 0 point is a decimal value, decimal 0, so this number is also extremely nearer to 1. So either x can have some value which is more than 1 but less than 1, doesn't matter, but it should be very nearer to 1, then this symbol is valid. But you have to understand that x cannot become equal to 1. Main thing, this is the main thing. The value of the x becomes extremely nearer to 1, but x cannot become equal to 1. Bas, this is the thing. This is the concept of the limit. Bas, that we have to understand. So what is the concept of the limit? Whenever we write limit x tending to 2, we have to understand x cannot become equal to 2. Okay? But the value of the x extremely nearer to 2. Simple thing. This is the concept of the limit. Bas. I think the limit concept is clear to you. So just like see, if I'm just going to write that, if I'm going to give an expression, x square minus 4 by x minus 2. Okay, limit x tending to 2. If I just going to tell this is to find the value, what to do? What to do here? Simple thing, because since x tending to 2, by x extremely nearer to 2, almost x is equal to 2, but not equal to 2, x almost equal to 2, it is not. But so how to do that? So we can tell that x minus 2, since x and 2 are very near, but they are not equal, that's why this portion, denominator portion, cannot become 0. That's why I just can write x minus 2, because x, this is a 2 square, x square minus 2 square, x plus 2 divided by x minus 2. So since I can write like this way, what I can write like this way, limit x tending to 0 here. So x minus 2 are cancelling out both sides. So what is the result is going to come? X plus 2. So now here I can put, since x is extreme in the limiting condition, in the limiting case, in the limiting situation, this value is going to become 4. Because I can say extreme, in the limiting situation, I can put the x is equal to 2. So ultimately, whenever the x is tending to 2, the expression is going to tend to 4. And ultimately, just we can approximate, it is 4 almost. In that way, just we can find this value of this term. I think children, you are understanding the concept of the limit. Okay, it is clear. Similarly, just we have discussed another term, that is a function. So what is this function is actually? Function, just like see, function is something, just if I just going to put some value of, suppose writing condition is fx. Fx means it is a function of x. Fx. It is a function of 1. If I put some value of the x, immediately it will just give some result. It will give some result. So suppose a function of fx is equal to x cube plus 4. Let us think. So this function, it is dependent upon x. It is x function. X function. So now, if I am just going to put the f of x is equal to 2. Okay. When x is equal to 2, what is the value of the function? 2 cube plus 4. So, 2 cube mane koto? 8 plus 4 mane 12. Therefore, whenever I am going to put some x in the function, it is giving some result. So the function means it is a dependent variable. It is a dependent variable. This x cube plus 4. This is a dependent upon x. Dependent upon whom? Dependent upon x. Understanding my point. So similarly, I can take fx. I can think that fx is equal to y. I can think. So what is the y? I can think that just like previous example, x is cube plus 4. This is the thing. So y is a function of x. Y is a variable. X is a variable. Variable which is varying. X is varying. Y is also varying. Simultaneously, if I put some x, I am going to get some y. Okay. So similarly, so if I am going to plot some graph x and y, I can have some graph. If I just going to plot a graph of x and y, putting the values of x and y simultaneously, I am just going to have a graph of the x and y. Okay. So some graph can be linear, some graph can be curved, some graph can be just like dependent upon the nature of the function. I can plot a graph of x and y. This is function. I think children, you are understanding my point. Okay. So now, why this concepts of the function is going to come? Just like the lot of applications of the functions we are going to have in the physics. A lot of applications. Just like see, with the time, with the position, with the this kind of variables, just like time is a variable, time is changing. Position of a particle, it is changing. So dependent upon the time, dependent on the position, and dependent upon a lot of things, a lot of situations can change. Just like see, a particle moving. So displacement of the particle is going to depend upon time. So displacement is a function of time. Just like I can write, suppose just like see, a object, a particle, whatever maybe, an object is moving with a uniform speed, 2 meters per second time. Just like say, I'm just going to give an example. Object is moving with the 2 meters per second is the speed. So we can have like this way. Displacement d is equal to 2 into t plus, if I just going to think that initially it was having a displacement 5. Suppose if I'm just going to plot a graph, it is a time, it is a displacement d. So when am I going to put a time 0? I'm going to put a time 0. What is the displacement? 1, 2, 3, 4, 5. Here, the displacement is here. Now the time increases and the particle is also moving up because displacement is increasing. I can have a graph like this way. more and more time going, displacement is increasing. I just can see from here. I can see if the displacement like this for 5 minus 2t, the graph would have reduced, dropped. Whenever this time increasing, the displacement is decreasing. The graph is coming down. Understanding my point? Similarly, so displacement is a function of time. You can see, but still, it is a linear graph. It is a linear relation is existing because the power of the time is 1, displacement having power 1. That's why it's a linear relation is existing between the displacement and time. So, in this manner, we can observe that lot of variable is dependent upon other variable, just like the displacement is dependent upon the time here. Displacement is dependent upon time here. So the displacement, I can write it here, displacement is a function of time, just like a y is a function of x in the previous example we have seen. Similarly, displacement is a function of time here. So in this way, a lot of applications we can have. One variable dependent upon other variable. So one variable is a function of other variable. So that's why the function is very much important in physics. Okay, we have to mathematically apply that thing in physics. Okay, understanding my point. So we have seen the limit, we have seen the function, mathematical function. So these are the these are linear functions. We can have a lot of non-linear function, curved function we can have. We will see that. Okay, fine, very good. Now see, we are going to observe now. We will see that the differentiation. What is the differentiation? This differentiation. What is differentiation? What is differentiation? That we have to understand properly. Okay, children. So you can see that you can see whenever one variable is changing with respect to another variable, just like in the function we have observed, one variable changing with respect to another variable. Okay, what to think about that? How to think about that? Just like a person, rich person, his money is increasing with time. His money increasing with time. Just like see which we can think about. So I can think that the amount of the money is dependent upon time, just like in the basic way. With the time it is increasing. Just like a person's children, his height is increasing. So we can think that height is a function of time. Height is a function of time. So now in this situation, if I just going to think that at a certain time, what is the rate with which the increment of the height is going to change? But at a certain time, what is the rate with which the money of the person is going to change? That is the most important. Understanding my point? Rate. What is the rate with which one variable is going to change with respect to another variable? Try to understand, children. So we have to find the rate of change of some variable with respect to another variable, rate of change of height with respect to time, rate of change of property, money with respect to time, rate of change of displacement with respect to time. All these things, all these factors are most important. What is the rate with which something is going to change with respect to another variable? Understanding my point? Very good. So now see that suppose I am going to think that y, it is a function of x. Y is a function of x. Okay, no problem. y is a function of upon x, the value of the y is going to depend. Which now if I want to find the rate of change of y, with respect to x. Suppose I'm going to think. Suppose you think that 2x plus 3. This is the relation between y and x. Suppose so how can I find like this way? This is x, this is y. I can plot a graph like this way. I can have a graph like this way. Now suppose I'm going to take certain point. This point, suppose this is point 1, this point, the point 2, point 1, point 2. This point 1 having a coordinate x1, y1. This point 2 having a coordinate x2, y2. Isn't it? So now within the change of x, this is x1, this is x2. So what is the change of x? This much is the change of x. Just like I can put some color here. This is the change of x, this much. This is the change of x. What is the change of x? x2 minus x1, isn't it? Okay. And this is y1, this is y2. Okay, so if I drop a perpendicular from here, you can see that this is the change of phi. This one is the change of phi, this much. This much is the change of phi. So what is the value of this change of phi? This one is the y2 minus y1. Now what we require rate of change of y with respect to x. So you can see, due to the change of x, what is the change of x? x2 minus x1. This is the change of x. If due to this change of x, if I'm going to have change of y, y2 minus y1. This is the change of x, this is the change of y. So if I want to find the rate, so due to the change of this much of x, there is a change of this much of y. So for the change of unit x, what should be the change of y? Understanding my point? Just like simply, just think about within 2 years, increment, the height of a child has increased 6 inch. Within 2 years, there is a change of height 6 inch. Within the change of 2 years. So within 1 year, if I want to find the rate of change of height, within 1 year, what is the change? 6 inch by 2 years. Means 3 inch per year. So can I tell this is a rate of change of height with respect to time? Time here we are measuring with the years. Per year, 3 inch change of height is going to occur. Something. Rate of change of height. Similarly, here the change of y this much, change of x this much. The rate of change of y with respect to x is this much, change of y divided by change of x. So let us think that if I'm going to think that y2 minus y1 is equal to delta y and x2 minus x1 is equal to delta x. So can I think that, can I tell that then this thing y2 minus y1 divided by x2 minus x1 is equal to delta y divided by delta x, this thing, isn't it? Change of y by change of x, that is the rate of change of y with respect to x. That is the rate of change of y with respect to x. Simple thing. So we can just like tell that this is the rate of change of y with respect to x. We have found an expression. Actually speaking, that is what? That is y2 minus y1 divided by x2 minus x1. There is a thing that you can see. This is my y2 minus y1. This is my y2 minus y1. This is my x2 minus x1. So this length divided by this length is, if this angle is theta, so this angle is also theta. This is theta. Actually, if I just going to think that this is a straight line, this straight line, if this angle is theta, this theta is actually is what? It's the slope of the straight line. This is the slope, isn't it? Just you know, in the mathematics, the slope is the slope money. What is the angle it is creating with the x-axis? Tan of that angle, tan theta. So tan theta is equal to y2 minus y1 divided by x2 minus x1. So this is the slope of this straight line. তার মানে delta y by delta x মানে y2 minus y1 divided by x2 minus x1 actually means tan theta. What this tan theta is? This is the slope of this straight line. The amount of the angle the straight line is going to create with the x-axis. Tan of that angle is called slope. তার মানে it is telling that if I'm going to able to find this slope, we are finding rate of change of y with respect to x. Bas. If I able to find the slope of this line, slope of this graph, we can find the value of the slope. The value of the slope is the delta y by delta x. y2 minus y1 divided by x2 minus x1. This is the this thing. Okay. Ultimately now so we found the rate of change of y with respect to x, and you can see any position in the straight line, the slope is fixed. If I just going to think that at this point, just like new point, if I just going to think that, you can see this is a tan theta. If I would take here tan theta, this is, so each and every position this angle is remains fixed. So the straight line having a uniform slope, constant slope. So the rate of change of y with respect to x is fixed according to this straight line graph. Rate of change of y with respect to x is fixed. Since this tan theta is fixed, the slope of this straight line is fixed. I think children, you understanding my point, isn't it? Okay. If still if you have the problem, you just can ask us. Now you can see that if in the previous case I just drawn a graph that is a straight line graph. It is not necessary that every time I'm going to have a straight line graph. I can have a equation like y is equal to x square. It is not a straight line graph. It is a curve, just like it is a parabolic curve. It is like this way. Y is equal to x square. We can have a graph like this way. I plot this one. Like this way. Okay. No problem. So if I'm going to have it this kind of graph, this kind of mathematical expressions, you can see that if I take 2 points, like 2 points, 1 point and 2 second 2 points. What if I this is a point 1, this is a point 2. Okay. Point 1, point 2. Okay, so the point 1 having coordinate x1, y1, point 2 having coordinate x2, y2. Okay, if I'm joining point 1 and point 2 by a line, it's a chord. By a chord I'm going to join 2 points by a chord. Okay, so now here the same thing that I can have a slope here, I can have a slope, I can get a slope here, just like change of y, delta y. I can have I can have just values like y2 minus y1 divided by x2 minus x1. Okay, so this is the, I can see that this, there is a slope theta, tan theta. Okay, but if I just going to shift this point 2 nearer to 1, I'm bringing the 2 nearer to 1. Now what I can write according to limits theory, point 2 is tending, is moving, it is just coming towards the point 1. More and more and more, the point 2 is going to come nearer to 1. What the thing is going to happen? You can see this x2 minus x1, this x2 minus, because you can see this is x2 minus x1, isn't it? And this portion is y2 minus y1, isn't it? This portion y2 minus y1, this portion x2 minus x1. So we can observe that here, when this point is moving towards the point 1, this length is going to reduce. So ultimately, in the extreme situation, or when extremely 2 is, when a point 2 is very near to 1, we can tell that this change of x2 minus x1, let us think this is the delta x. In that situation, when 2 is very near to 1, when 2 is very near to point 1, then delta x tending to 0, extremely small. Length is reducing and becoming extremely small. So ultimately there's so small, this length is extremely small, that you can think that this chord is going to become tangent at that point. Simple thing. There is a 2-point joint. This is a point 2, this is a point 1. In this point, if I develop a tangent, the chord is ultimately going to become tangent when delta x, when a change of x is extremely small. I think, children, you are understanding my point or not? Are you understanding my point? I think you understand. So in this situation, we can tell that the delta x, when extremely small, then we can tell that this chord is going to become a tangent. So ultimately, this thing is what? You can see x2 minus x1 is delta x. y2 minus y1, we can also think that let y2 minus y1 is delta y. When this delta x is extremely small, similarly, this change of y, y2 minus y1, when they are very near, this 2 and 1, then y2 minus y1 is extremely small. Okay, then this is delta y. Tan theta, this is going to become the slope of this tangent. The slope of this tangent. This is the tangent. So suppose alpha. The alpha. Okay. So ultimately tan alpha, I can tell that is equal to delta y by delta x. Tan alpha, ultimately we can tell that limit delta x tending to 0, delta y divided by delta x, isn't it? That means the slope of the tangent at the point 1, slope of the tangent at the point 1 equal to limit delta x tending to 0, delta y by delta x. This is called differentiation of the y with respect to x. মানে rate of change of y with respect to x at this point on the graph. It is written as d dx of y. d dx. This operator, this is called the differentiation, d dx of y. মানে limit delta x tending to 0, delta y by delta x is equal to dy dx, bas ddx of y, bas. Ultimately it means what? It means it is the slope of the tangent at a particular point. Slope of the tangent at a particular point of the graph. Okay, so now children, you can observe that children, if you have any doubt, you can ask me. You can contact Vidyanest and you can ask me any kind of confusion, any kind of doubt, you can ask us. Okay, just like see, just like I'm going to tell that this is y, this is x, okay, and this is my graph. So at this point, point 1, I can have a tangent, point 1. I've chosen a point 2. Again, I'm developing another tangent. You can see that if this is theta 1, this is theta 2. You can see at each and every point on this graph, it is a curve. Each and every point on this graph, if I develop different tangent, I can have a tangent here, I can have a tangent here, I can have a tangent. In this way, I can have different slopes, because this angle theta 1, theta 2, all the angles are going to change. All the angles are going to change. So therefore, it is a variable slope graph. The slope is variable here. Slope is variable here. The slope is changing here. I think children, you are understanding. Okay. So now in this previous case, we have observed that previous case means in the straight line case, the slope was constant. For this, the slope was fixed at each and every point on the graph, because it was a straight linear graph. The slope was fixed, but you can observe here the slope is not fixed. Here the slope is something, here slope is another something. In this way, the variable slopes are existing. Okay, so but ultimately the differentiation of y with respect to x, we can write limit delta x tending to 0, delta y by delta x, change of y by change of x when limit delta x tending to 0. This is the differentiation of the y with respect to x, ddx of y. So children, you understand this point, I think so. Now for finding the differentiation, we have a simple formula. Just like see, if the y is a function of x to the power n, y is x to the power n. So now x to the power n, n can have any value. N can be 2, n can be 5, anything like this way. So then dy dx x to the power n, the formula you have to remember. The derivation of the formula is not important for the physics. You have to remember n into x to the power n minus 1. Simply remember this thing. Children, I think you understand my point. You understand my point, isn't it? Understanding my point? Mane, suppose x y is a x to the power 5. So apply the formula. Differentiation of y with respect to x, the d dx x to the power 5. Instead of y, we are going to put that thing, the formula key n, mane 5. Here the value of the n is 5. Then x to the power n minus 1, 5 minus 1, 5x to the power 4. This is the result. Understanding my point? Suppose uh, n is equal to 8. So when y is equal to x to the power 8, so let dy dx ddx of y ddx x to the power 8 মানে n এর value 8, x to the power 8 minus 1 মানে 8 into x to the power 7. This is the value of dy dx. I think you understand my point. Simple formula, very simple formula, no problem. Okay, so now this is the thing we can have. Fine, very good. Okay, now see, just we can observe that just like suppose y is equal to 6. Y is equal to 6. Right. Then dy ddx of y. Then what to do? ddx of 6. 6 is a fixed value. 6 is not a variable. It's a fixed value. Y is a variable. Why is the value of the y can change? But 6, it is a 6. 6 is 6. 6. Value of the 6 cannot be changed. So, what is the rate of change of 6 with respect to x? No, there is no change. So, it should be written as 0. But you remember that any constant value, any constant number, if I differentiate, it result comes 0. Simple thing. So, constant, any constant value, whenever I am going to differentiate, the result is going to come 0. Simple thing. So, similarly, if I am going to think that any constant is multiplied with a variable, just like 2x is x to the power 3, y is 2x to the power 3. So then dy dx, if I differentiate d dx of 2x cube, we can write here in this situation, whenever a constant is multiplied with a variable, 2 is a constant but x cube variable. So this constant is going to come out. This is a rule. You have to remember, 2 is going to come out because we cannot differentiate 2 because constant, if only constant is existing, differentiation 0. But if only constant is not existing, the constant multiplied with a variable. So that's why the 2 is going to come out. Then differentiation of the x cube. Then 2 into, what is the value? You can see x to the power 3. N into x to the power n minus 1, 3 into x to the power 3 minus 1, money 3 into 2, 6 x square, 3 minus 1, 2, 6 x square. Children understanding my point or not? Children understanding my point or not? If anyone having any confusion or doubt, you can tell me. Any confusion or doubt, you can tell us. Any kind of doubt, you can tell us. So now, if we have multiple functions are added, just like see, any function of x, suppose x is cube plus 4 x to the power 6 plus 5. You can see it is a function, it is a function, it is a separate function, the constant, but still just you can think it is a function also. So it is a function, just like this, I can think this is a y. So what the rule is that you have to separately differentiate this one, you have to separately differentiate this one, you have to separately differentiate this one, and you have to add the results. Simple thing. What I told? You separately differentiate each and every one and add the result, you will get the differentiation result. Okay, so that's why now the differentiation, how can I do? Dy, so just put x is cube plus 4 x to the power 6 plus 5. So separately differentiate d dx x is cube plus d dx 4x to the power 6 plus d dx of 5. So now this one, if I differentiate 3x to the power 3 minus 1 plus 4 is going to come out d dx of x to the power 6 plus constant term differentiation will give 0, 3x square plus 4 into 6 x to the power 6 minus 1. This is 0, we need not regret to write. 3x square 24 x to the power 5. This is the final result. If I differentiate this one with respect to x, I'm going to get this result. I'm going to get the result. I think children, you understanding my point? Are you understanding my point? I think you understand my point. Okay. This is a procedure through which we differentiate. Simple. Okay, children. If you have any doubt, you can just ask us question, any kind of doubt. আচ্ছা, বোঝা যাচ্ছে? ছেলেপুলে কোনো বুঝতে পারবে? এটাও রেকর্ড হয়ে যাচ্ছে। ঠিক আছে, থাক, একটু বসবো, তারপর আবার নেবো।